Hello everyone, my name is Jordan Clark at Vanderbilt University, and today we're going to do a casual introduction to the theory of measurement. Now what is measurement? Measurement is simply assigning a value to a variable, a person, a place, a thing, or an event in nature, or in our human world. Measurement is coming up with representations that we can abstract and then figure out things about our world. Why is measurement important? Well, we're always doing it, and it also applies to all fields, not just psych or research methods. People in finance, for example, are constantly measuring stock prices or changes in value, input and output. Every time you measure something, you make a set of assumptions. And that's why it's important, because these assumptions underlie nearly all the decisions we make in today's data-centric world. So that's why measurement's important. Let's talk for a minute about the two foundations of measurement, which are concepts of reliability and validity. When thinking about reliability, I want you to think about one thing: consistency. If you take this bullseye, for example, and you imagine every time you're taking a measurement, you're firing an arrow. If your measurement process is reliable, you will hit around the same point every time on the bullseye. It may not be the center, but you'll get around the same results with every measurement taken. Now, it's not the same as accuracy. That's why we need validity. Validity in measurement is how well the measurement process and the data that you're collecting represents the thing that you're actually interested in. So think about someone's math intelligence, and you want to measure their capacity to do algebra. If you gave them an algebra test, that would be a fairly valid measure. If you gave them a geography test, that would not be a valid measure of their math intelligence. And so this is important as you go about your work, especially in education, looking at reliability and validity, because ultimately you need both when it comes to effective measurement. Let's talk briefly about scales of measurement. When you collect data of any kind, there's different levels at which you can measure things. There's also different classes of data, as I'm sure you've noticed. One class of data, the most foundational, is called nominal. Nominal data, it's easy to remember because nominal just means a name, a class, a category. Think about gender. You have male, female. Some people identify as neither male nor female. These are all classes of persons. None of them are necessarily better than the other. If you think about race or ethnicity, that's also a class of persons. It's nominal in nature. And theoretically, we could have unlimited categories if we wanted to. Ordinal data is the next step. Ordinal data is the same as nominal in the sense that you have categories and not necessarily numbers. With ordinal data, there is a natural gradient. For example, think about places in a race. In a track race, you have first, second, third, and fourth place finishers. That's ordinal data. You can think about grades in school, kindergarten, first grade. These are ordered classes. Interval data is not talked about much because it's kind of rare. Interval simply refers to quantitative data, so numbers with equal space between observations, but there's not an absolute zero. The only example really that pertains to this data is Fahrenheit and Celsius. There's a few more. Ratio data is basically everyone's dream data. It's numerical data that has an absolute zero. So if you think about weight, height, age, these things, when you have zero as a value, means you have nothing, or you are the lowest possible amount of those things. That's ratio data. So you have nominal, ordinal, interval, and ratio. Those are the scales of measurement. We'll talk about more next time.